So I've got some more identities here for you. The half-angle identities are pretty ugly, and sometimes that's exactly what I call these, the uglies. And that does help me remember what the formula looks like. So let me tell you, these formulas have a plus or a minus. It's not like the quadratic formula. You've got to figure out which one you're using. Then there's this huge radical. And then inside of the radical, a fraction. What? Okay, so the good news is they all look pretty similar. So we could get them all ready here for you. And inside of the first one, sine of half of x. So whatever x is, this is a half angle. I don't know half angles, so we'll have to have a formula for it. And inside it's 1 minus cosine of x divided by 2. Now 2 is in the radical, so I want you people to draw nice, big, tall radicals. That 2 is underneath there. For cosine of a half, it's 1 plus cosine of x. Oh, look at that. Cosine matches with cosine. It's the same. Same gets a sum. And when it's different, different gets the difference. Okay, try to remember who gets the plus. The cosine gets the plus because it matches. And that's a 2. And how do you make a tangent? Well, a tangent formula could be the sine over the cosine. So if this goes on top and that goes on the bottom, but of course I'll cancel the 2's out. So 1 minus cosine of x divided by 1 plus cosine of x. And so let's put a couple of rules here. This right here, that is the half angle. See how it says half of x? But this x, that's the full angle. That's the full x. And the full x is something you know from the unit circle, but the half one we don't. Okay, we're going to make a couple of more. So let's take this tangent one right here, because we're going to make a couple more versions that are actually a lot easier to use than that. So let's take the plus minus of 1 minus cosine of x divided by 1 plus cosine of x. And inside that radical, I'm going to multiply by, oh, you bet, a conjugate. So let's multiply top and bottom by 1 plus cosine of x over 1 plus cosine of x. So some people might be thinking, well, why didn't she pick 1 minus x? Don't worry, I got more space. I'm going to do that version next. So let's just use this conjugate. So the numerator is going to be a difference of squares, which is 1 minus cosine squared of x, but the denominator is the exact same quantity twice, so that's quantity squared. Now I can go ahead and simplify 1 minus cosine squared to sine squared of x, and now I see a lot of things that are being squared. Sine squared being square rooted. Well, that can come out of the radical, and that's just sine of x. How about a quantity squared? Can that come out of a radical since it's the entire quantity? Yes. Remember when we studied other things? Things like the square root of 1 plus u squared. When it's just the u, you cannot take it out. But since it's quantity squared, you can. So here's another great version of tangent. Notice the radical disappeared as well as the plus minus. So you don't have to decide or try to figure out which one you're going to pick. The sine value automatically appears. Okay, let's go ahead and do that last version. So let's take 1 minus cosine of x over 1 plus cosine of x. But this time, we're going to multiply top and bottom by the other conjugate, 1 minus cosine of x. Okay, something very similar happens again. The plus minus is going to disappear. That's why I don't write it. The numerator is quantity squared, but the denominator is a difference of squares. In fact, it's the same difference of squares as up there. So we've got 1 minus cosine of x quantity squared divided by sine squared of x. So both of those can come out of the radical. And we have 1 minus cosine of x over just sine of x. So you see essentially what happens here is if you have the denominator twice, then it's that denominator. If you have the numerator twice, it's that numerator. Of the three of these versions, the one that I recommend using, that's the easiest for calculations, is this guy right here. Because the denominator is the most simple, rationalizing and cleaning up your work is the easiest. This one's going to be a little more work, and that one's just a pile of work. Okay? Unfortunately, we don't have a lot of options of sine and cosine. And they are ugly, so make sure you go ahead and memorize those. Okay, we're going to go ahead here and work on half angles. So if we have angles in quadrant 1, now quadrant 1 angles range from 0 to 90. What's half of that? Well, 0 to 45. Quadrant 2 angles range from 90 to 180. What's half of that? Half of 90 is 45 to 90. Angles from quadrant 3 are between 180 degrees and 270 degrees, and if you chop them in half, how much do they measure? They're between 90 and 135. And angles from quadrant 4 are between 270 and 360 degrees, so half of that would be between 135 and 180. So let's look at these. Angles that start in quadrant 1 or 2. If you chop them in half, they both, let's just put a line here, they both end up in quadrant 1. What is she doing? Well, I'm trying to figure out where half angles are going to be. If your angle starts in either 3 or 4 and you chop it in half, where does it go? It goes to quadrant 2. So all angles around the circle either go to quadrant 1 or go to quadrant 2. And so this is how we're going to do the problems to figure out some things. Okay, so first of all, 15 degrees. 15 degrees is right here, and that is the half angle. So where's the full angle? If 15 is the half, then 30 degrees is the full angle. So when you're doing your problem, it's going to help to know that the half is the value from out in front, and the full angle, let's go up here and show you what I'm talking about. The half angle is that sign right there. But the full angle is what you calculate with inside there. So this is going to be helpful to know. I'll do an example on the next page and show you guys. Let's just practice one more time. If we have 67.5, so that is obviously the half. 67.5 degrees is the half. So where's the full angle going to be? Well, 67.5 times by 2 is 135. 135, that's the full angle. So if the full angle is in quadrant 2, half of it's in 1. Okay, let's do some calculations now that we kind of see where these things are all coming from. So the first problem is sine of 15 degrees. And I know that we studied this already doing sum and difference, but now we're doing half angle rules. Okay, and the rule says plus or minus, let's see, plus or minus the square root of 1 minus cosine of x over 2. So let's figure some things out. 15 degrees is right here. 15 degrees is the half. And 30 degrees is the full. So what we're going to do is we're going to take this sign right here, okay, and that sign is determined by the half angle. But this value right here, determined by the full. So I'm going to start this problem. Should I pick the plus or the minus? Since 15 degrees is in quadrant 1, I see it, I'm going to pick the plus. Now I'm going to start the calculation. Big square root, 1 minus. I have to say cosine of the full angle, 30. Okay, at this point, we should be able to calculate with our unit circle. Divided by 2. Big radical, people. I want to see a nice big radical sign. Okay, so Now we have positive square root 1 minus. Cosine of 30 degrees is radical 3 over 2, but now it's all over 2. Okay, there we go. Let's write the 1 a different way. Let's write 1 as 2 over 2. And let's write 2 over 1 as 4 over 2. That's a very similar technique as to the last couple of sections. So all these denominators are going to cancel away, and we have 2 minus radical 3 over 4, since the denominators canceled. Now, can a 4 come out of a radical? Yeah, the 4 can. In fact, that would make it rationalized. So what we're going to do is we're going to draw a shorter radical, 2 minus radical 3. Big fraction bar, not inside the radical, but outside as a plain 2. These answers are going to look pretty ugly, and that's why I call them that. If you typed sine of 15 degrees in your calculator, you'd get a bunch of decimals. If you typed all this stuff in, you'd get a matching set of decimals. Kind of fun to see. All right, let's do the next one. 67.5 degrees. So the half angle is right here, 67.5. That's the half. And where is the full angle? 67.5 times 2, we said, was 135. 135 right here in quadrant 2. Okay, so when we do our problem, we have to pick plus or minus. Plus or minus. Looking at the half, are you going to pick plus or minus for a cosine? A cosine in quadrant 1. Let's pick plus. Big square root. The cosine formula is 1 plus cosine. Now we don't write the half angle, we write 135, the full angle, all over 2. All right, let's get started. Now it's unit circle time. 1 plus, what's the cosine of 135 degrees? Negative radical 2 over 2. And then this is still over 2. Everybody's in the radical. I hope your radical is long enough. So a couple of things are going to happen. I'm going to write 1 as 2 over 2. And I'm going to write 2 over 1 as 4 over 2. That's a lot of 2's. A lot of 2's. So we can go ahead and cancel all the denominators. 2 minus radical 2 over a 4. Hey, can that 4 come out of the radical? Absolutely. You're going to notice a lot of patterns with these problems. 2 minus radical 2 all over a plane 2. That's the half value. The ugly formula. Let's try a tangent problem. Okay, tangent problem. The reason why I'm drawing these little diagrams here is we're going to do the same lesson again tomorrow, but it's going to be abstract, and so they're not going to be numbers, they're going to be alphas. So to kind of develop a technique that's going to work for all the days and not mess you up, that's why I'm doing it like this. So 165 degrees is right here, half. Not quite 180, 165. Now, what about the full? Where is 165 double full? That's 330. Wow, that's way over here, 330. So that's way bigger. That's halfway, that's the full way. Now, there's 3 tangent formulas, but the one that I highly recommended using, which is going to be easiest for our calculations, is 1 minus cosine divided by sine of the full angle. Let's write that down. 1 minus cosine of x over sine of x. And you don't have to figure out plus minus. It's just going to work out for us. So what we're doing is the full x, 330. The number you calculate with, you should know from the unit circle. 1 minus cosine of 330 divided by the sine of 330. Okay, it's unit circle time. 1 minus, what's the cosine of 330? Radical 3 over 2. What's the sine of 330? Negative 1/2. How should I write that 1? As 2 over 2? Okay, we've got a lot of denominators of 2, which means all those denominators cancel. And now we have 2 minus radical 3, and the denominator is negative 1. They're each going to get the negative 1, which means the final answer is negative 2 plus radical 3. This formula is the easiest because in the denominator you're only going to have one fraction, so you don't got to multiply by conjugates. That's why I recommend that one. All right, let's try a sine problem. Sine of 15 pi over 8. So what is the half? The half is 15 pi over 8. Half. Where is 15 out of 8? I know 8 out of 8 is right here. And again, 16 would be too much, so we're going to stop right here. Right here. 15 pi out of 8. Now, where's the full angle? Where's the full angle? 15 over 8. What's 15 pi over 8 times 2 if I double it? That's going to be 15 pi over 4. Ooh, okay, so let's try to find the full. 4 out of 4, 8 out of 4, 12 out of 4, 13, 14, right here in quadrant 4. 15 pi over 4. So the half is there and the full is there. So let's figure out sine is the plus minus. Should we go with the plus or should we go with the minus? Since your half angle is here in quadrant 4, it goes positive, negative. We're going to pick negative. Negative, big square root. What was that formula? I know it was a fraction with a 2 in the bottom. Since we're doing sine, it's 1 minus cosine, but we're going to fill in 15 pi over 4. 15 pi over 4. All right, let's do it. Negative, big square root. Now we've already figured out 15 pi over 4 is down here. So the cosine right there would be positive radical 2 over 2. How do I write the 1? As 2 over 2. How do I write 2 over 1? As 4 over 2. Every time it's that same technique. So we've got a negative outside. In the radical, we have 2 minus another square root of 2 over 4. Can a 4 come out of a radical? Absolutely. Negative square root 2 minus radical 2 all over a plane 2. Of course, all the answers start to look like each other because radical 2 over 2, radical 3 over 2 are our only options. How about another tangent one? 7 pi over 12. That's the half. Where is the half located? 12 out of 12 would be here. 6 out of 12 would be here. So half is right there. How about the full? What's 7 out of 12 doubled? Double it up. That's going to be 7 pi over 6. So the full angle is down here. 7 pi over 6. Okay, tangent has a couple versions, but remember the one that I recommend goes 1 minus cosine of the full, 7 pi over 6, divided by the sine of the full, 7 pi over 6. Remember, you don't do weird things like put radical 3 over 2 or 1/2 in here. This says sine of angle. The next step is where we use our unit circle knowledge. So what is the cosine for 7 pi over 6? Negative radical 3 over 2. Oh, lots of minus signs. Those are going to cancel. How about sine of 7 pi over 6? That's negative 1/2. All right, let's do some more changing. 1 is going to become 2 over 2. Negative 1/2 is going to become negative. Oh, what am I doing? It already had a 2. Abort. Erase that. It already had a common denominator of 2. So that means we've got 2 plus radical 3 all over a 1, a negative 1. They're each going to get the negative 1. So the final answer is negative 2 minus radical 3. Okay, our last one is a cosine. Pi over 8. Pi over 8 is right here. Here's the half. And where's the full going to be? What's pi over 8 times 2? Pi over 4. So the full is going to be right here. Here's the full angle. We got the half angle. We got the full angle. Cosine. It's pretty ugly. It's got a plus or a minus. The plus minus is determined by this guy right here. He's in quadrant 1. Cosine is positive. Inside, we've got 1 plus cosine, and then you write the full angle here, pi over 4, all over 2. All right, let's go ahead and finish this up. We've got cosine of pi over 4, radical 2 over 2. This is a 2 over 1. Here's where I got to make some 4s. So this is 2 over 2. This is 4 over 2. Now they all have denominators of 2. So we have 2 plus square root of 2 all over 4. Inside of the radical, can the 4 come out? Absolutely. At this point, make sure your divide bar is nice and big so that 2 is not trapped in there at all. Okay, half angles. Please fill out the formula card on the next page and start memorizing these formulas yesterday.